We're here to test out the propulsion capability of the latest wave of unmanned aerial vehicles, UAVs. This is a model of the UAV system that we're testing out here. It's called the AD-150, made by American Dynamics Flight Systems. And what's unique about this vehicle is it's going to have the ability to actually lift off vertically like a helicopter and then take off horizontally at speeds of up to 340 miles an hour. It'll do that with the capability of this mechanism here called a nacelle. It looks like a propeller. It's going to enable this UAV to actually lift up and then transition like this for horizontal flight. What we're going to be testing out is the ability of this mechanism, the nacelle, to actually make the transition to avoid a crash and actually get this thing into flight after it takes off horizontally. What they want this UAV to be able to do is to fly ahead of the Osprey helicopter, which actually drops off troops and carries payloads, to fly ahead of it, maybe pick out some intelligence, and even strike targets if necessary. This will have the capability of striking targets, of gathering intelligence, and also carrying a payload of up to 1,000 pounds. Now we're going to test out the nacelle's propulsion capability here at the Glen Martin Wind Tunnel at the University of Maryland. This has the capability of generating winds of up to about 240 miles an hour, but we're not going to be going nearly that fast with the wind in this chamber. It's going to be about 30 miles an hour. So let's go and see how the test of the propulsion capability of the nacelle is going to go. Into the wind chamber now. They're using smoke to test out to actually be able to visualize the airflow, see if this thing really has the capacity to transition from a vertical to a horizontal thrust and to be able to propel the UAV forward. This nacelle is smaller than the actual nacelle that's going to be on the UAV. That one's a lot bigger because the UAV we're talking about is about 17.5 feet from wingtip to wingtip. This is just to test out that thrust capability. We're now going to talk to the president of American Dynamics, Wayne Morse, to see how it's performing. All right, Wayne, you've seen it now in the wind chamber. You've already tested this thing out on the computer. Does it have that thrust capacity to actually lift off vertically and then transition to a horizontal flight?
So far in the test, the results are extremely encouraging, absolutely.
Now, the military is going to want to put wounded soldiers on UAVs, maybe have a human payload on there. Does this UAV have the capacity to do that?
Yes, with the 1,000-pound payload from the AD-150, it can actually easily do that mission. But there may be some future testing required, but it's well within its capabilities.
All right, Wayne, well, good luck. Thanks very much. The makers say that they want to have the first flight ready by January 2013. Each one of these vehicles is going to cost the military a few $1 million, but the manufacturers say that's a lot less than the average UAV of similar size. Brian Todd, CNN, College Park, Maryland.